In this video, we're going to look at transitional constraints inside of Autodesk Inventor. Now, the transitional constraint is a way that you can have one surface follow another surface. The most common example of this is a cam and a follower. However, you can utilize this whenever you have two surfaces that need to maintain consistent contact in your design. Now, some limitations you look at when you look at this particular type of constraint is that your following surface needs to be contiguous. You need to have a very consistent curvature where you don't have broken up sharp edges. So here with this cam, I have continually tangent edges going all the way through these different curvatures. It would also work fine if I had a spline and they were all connected through a tangent or at least G2 smooth condition as well. Now, this is also one of the trickiest constraints to set up, depending on how your design is put together. Generally, what happens if you choose incorrectly or improperly when you're going through the command is it might jump to the other side of the face that you want it on. As an example, if I go up to my constrain command and I choose the transitional constraint, which is the third tab, notice we have very few selectable options here. We have a type in selection 1 and 2. If I expand the chevrons, notice that this is also not able to have a limiting control. For my selections, the first selection you make is going to be the geometry that is the moving face. The second selection you make will be the transitional face, which will be my cam. Now, the selection you choose first, it does matter if you click on the top or bottom of the cylinder. In a very similar way to as when you're creating a tangent work plane, what side of a face you click on. The software will try to make the best assumption that it has based on your criteria that you pick. Now, if I choose this top face here, and the bottom face down here for my transitional face for selection 2, it looks fine. I'll go ahead and apply that. But look what happens. It actually shoots down to the other side of this. Therefore, it actually comes out of the slot that I need to maintain that follower in. So to alleviate that issue, we can set up a limiting constraint to control how far this particular follower can move. I'm going to cancel this and delete the transitional constraint that I just added by right-clicking on it and choosing Delete. I'll move this back up here, and I'll start by creating a new limiting constraint. This will be a mate constraint. I'm going to limit the axis to a work plane that's defined inside of the block 1. Work plane number 2 is set up here at the top, and for my offset, I'll have a maximum value and as well as a minimum value. Now, depending on which direction I'm going, plus or minus, you might have to play with this. Let's see what -5 looks like. And to help get your minimum and maximum values correct, you could come up here and adjust your offset value to see which way it's going. So if I do -5, I can see that's going to be the limiting direction I want. So my minimum will be -5. I'm not going to use 0 as my offset position either. So my max is 0, minimum -5. I'll apply that and close out. Now, if I try to pull the follower down, it stops when it gets to the -5 value for the offset. Let's try our transitional constraint again now. Here I'll choose the same top part of the face, and then I'll choose this face here for the transitional. I'll hit OK to accept that, and now I have my cam and follower, which will consistently follow this as the cam rotates. So here I'm just grabbing it and rotating it around. Now you can set up an angle constraint to control this rotation, but I basically achieved my design criteria by having the cam and follower interact as you see here.